35,000 feet above the Bering Sea.
Anchorage northwest 85.
Confirm that you are aware that we have declared an emergency.
A Boeing 747 is in serious trouble.
Can't do that. There's too much traffic.
We're calling this a red emergency.
Red emergency is preparing for the worst.
The crew can barely control the plane.
It was a very confusing situation. It was something that they had never done in training.
They need all the help they can get to have any hope of bringing the plane and its 386 passengers safely to the ground.
If there's ever going to be a time you fly the perfect approach, it's got to be this one.
Mayday, Mayday.
Northwest Airlines Flight 85 is making its way over the Bering Sea. It's after 5 p.m. Dinner service has ended, and passengers are settling in for a long flight. The massive Boeing 747-400 has just flown over Alaska and is now almost halfway through a 13.5-hour journey from Detroit to Japan's Narita Airport.
Hello, gentlemen. Frank, how are things?
35,000 feet.
Captain John Hansen is a career pilot. He's also a flight instructor for the Boeing 747. 6.5 hours into the flight, he's about to hand over the controls. On long journeys, it's common to have 2 flight crews.
The trip was long enough that we put on a full augmented crew. We had 2 captains and 2 co-pilots.
They fly in shifts to prevent fatigue.
Why don't you guys give me a ding about 20 minutes before you want me back up here, okay?
Mike Fagan, a Vietnam vet with 25 years flying experience, is the fresh first officer.
Everything was normal, and we didn't expect to have any problems. We've flown this flight many, many times.
Frank, I'm taking the lasagna. You get option B. Does option B include starving?
He is joined by Captain Frank Geib, who has over 11,000 hours of flying under his belt. Pilots refer to this aircraft as the Queen of the Skies. It's equipped with a private cabin for the flight crew. Here, Captain Hansen and his first officer, David Smith, will have a 5-hour rest break before returning to the flight deck.
Dave Smith had worked with me, and we were going to read for a while, perhaps nap in the bunk, and wake up for descent to Tokyo.
You sure you're not hungry?
Trust me, I'm good.
Flight 85 is more than 6 hours from landing at Narita.
The aircraft took a dramatic roll to the left. It went from 35 through 40 degrees of bank.
For no apparent reason, the pilots have lost control of their plane.
The airplane took a lurch, like nothing I had ever felt before. And I kind of had to catch myself.
It was a very sudden yawing movement. It's the type of thing you only feel in a simulator when they're doing extreme things.
Captain Geib has only moments to react.
Did we lose an engine? Do we still have engines?
Still have all engines, that's not it.
The lives of 386 passengers hang in the balance.
The airplane was kind of shaking, and I knew the autopilot had been disconnected. It was quite obvious that something was abnormal.
In a matter of seconds, Captain Geib has disconnected the autopilot, pulled back on the control column, and leveled the wings. But something is still seriously wrong.
Frank, you got it?
Yeah, I think I've got it.
If it's not the engines, then we have a problem with the rudder.
The pilots have leveled the plane, but they are still having difficulty controlling it. The warning system confirms Guybe's suspicion.
Yaw damper lower.
A malfunction of the rudder system. The rudder controls the plane's yaw, its movements from left to right as it flies. It directs airflow to keep it flying straight. Less than a year earlier, American Airlines Flight 587 lost control of its rudder system and crashed into a neighborhood in Queens, New York, killing everyone on board.
We were very well aware of that, and there had been quite a study done on that. So we had actually just reviewed that event in flight planning.
This plane is in danger of suffering the same fate. Because of its size, the 747 has both an upper and lower rudder. They normally move in unison. For some unknown reason, the lower rudder has deflected 17 degrees to the left, and it's stuck there. The captain tries to keep the plane flying level and straight. He uses foot pedals to control the upper rudder, and the control column to move the ailerons. But he knows it's a stopgap measure that may not work for long.
I've got the airplane and the radios. You get the comm and see if there's a procedure for this.
The COM, or Cockpit Operating Manual, provides a list of procedures for emergency situations.
It says not to remove any pressure from the hydraulics, that's all.
That's not very helpful. Is there anything else? Are any other systems failing?
Not so far.
Hydraulics control several vital components, including the failed rudder. More failures could spell disaster.
How far to Narita?
About 6 hours.
Flying that far without full control of the plane is a huge risk.
P3, get them back.
When you're in the bunk, you're used to hearing the P3 only at times when it's time for a shift change. When you hear it at an odd time, it means come back, because something out of the ordinary has happened.
Anchorage is 2 hours behind us. Call them and declare an emergency. We're turning around.
Anchorage, this is Northwest 85.
But even contacting Anchorage is a problem.
Anchorage, this is Northwest 85.
Air traffic control centers have a limited range. In the middle of the sea between the two continents, the plane is in a dead zone. No one in Anchorage knows they're in trouble. In the cabin, passengers don't know the scale of the problem. Many passengers assume it was only turbulence that caused the sudden jolt.
See if you can reach 19.
The pilots attempt to contact another flight that's closer to Alaska,
Northwest 19, this is Northwest 85.
but the signal is weak.
Northwest 19, this is Northwest 85.
This is Northwest 19. Go ahead.
We have an emergency on board. Can you relay to Anchorage?
Roger. Stand by.
Okay, let's turn this around.
The plane goes into a very wide right turn.
Anchorage Control. This is Northwest 19. Northwest 19.
Go ahead.
Northwest 85 is requesting an emergency landing. What is
The nature of the emergency.
Hard over, left rudder.
The rudder is crucial for turning the plane around. Without it, the captain is forced to improvise.
We had no idea what the problem was. So Frank was very cautious on using the rudder, which means that he had to use full aileron to control the aircraft. But in the meantime, the aircraft is in a slip. And a slip is when the aircraft is not in a coordinated turn. The tail is off in one direction, the nose point in the other direction. In other words, it's a slip that goes like this.
Like a race car driver skidding through a turn, Captain Guybe is close to losing control.
Let's move it. What's happening?
We've declared an emergency, and we're headed back to Anchorage.
Indications?
Lower rudder is hard over 17 degrees to the left. We don't know why, and it's not responding. We don't know what else is wrong yet.
It took both hands to fly the airplane. We didn't know at that point whether the rudder was coming apart. All we knew was it was definitely a rudder problem.
This has never happened before. The pilots haven't been trained for this malfunction.
There's no procedure in the comm.
And the manual is of no use.
Well, we're gonna have to make one up.
35,000 feet over the Bering Sea, and an hour and 40 minutes away from the nearest airport, the pilots of this massive 747 are in uncharted territory. For the 386 passengers on Flight 85, the anxiety over the sudden dive has subsided. No one in the cabin is aware of the potentially fatal drama still unfolding in the cockpit. Without full control of the plane's rudder, the crew needs to fly another 1,300 kilometers to Anchorage.
Frank was the junior captain, I was the senior captain. And when I saw him battling the controls, I decided that I was gonna take over.
Hey, Frank, you've done a hell of a job, but I think I better take over now. If anybody's gonna ding this thing up, it's gonna be me.
I have no problem with that.
Okay.
Okay, Mike, you're gonna have to take control while we switch over. Are you ready?
I'm ready.
First Officer Fagan must now hold the yoke steady as Captain Geib relinquishes control of the plane.
I have control.
Any mishandling of the controls could send the plane into a fatal spin. The same delicate balancing act transfers control of the plane to Captain Hansen.
I was pretty appalled at how much force it took to fly this big, beautiful airplane. If the airplane is flying, even lousy, it's flying. And that's the bottom line. And it's headed towards Anchorage. So we're good to go for a while. Now we could begin to devote some thought to other things that had to be done.
The crew has no idea how badly the rudder is damaged. It could be seconds from tearing off altogether.
I can't tell whether the damn rudder's trying to leave the airplane.
What do we tell the cabin?
We decided the passengers really should know, so we wanted a liaison with the cabin, and Frank offered to do that.
I'll go back and tell them. The more they know, the better.
I agree. I think we should tell them exactly what's going on.
Kathy, we don't know if things are going to get better or worse.
Every single crew member knew that something major had happened to that aircraft.
We've turned back to Anchorage, and we're going to make an emergency landing.
The captain didn't try to hide anything, didn't try to pull any punches. He just flat out said how things were and that it could possibly be a very rough landing.
Kathy, we're calling this one a red emergency.
Red emergency is, of course, preparing for the worst. There may be a crash landing, there may be damage to the aircraft, there may be injury and or death to passengers and or yourself.
Hello, ladies and gentlemen. I'm Captain Frank Geib. We are dealing with a malfunction at the moment, and our crew is dealing with the situation as best we can. We need everybody to remain calm. And please, give your flight attendants your complete attention. I cannot stress how important your complete cooperation will be in order for us to make it to the ground safely.
The passengers, for the most part, were fairly calm.
I promise I'll update you with any new information as it becomes available. Thank you very much for your attention, and I'll talk to you later.
After a few minutes, you could hear some people crying a little bit. You could see people looking around. You could see fear.
We need to talk to SOC. We need suggestions.
We can reach them on HF.
The Systems Operations Center in Minnesota may be able to help. But to reach that far, the pilots must use high-frequency radio, which has a weak, intermittent signal.
HF radio is like when you were a kid and your best friend lived next door and you talked to him between your bedrooms with 2 Campbell soup cans with a string between them. About that level of sound quality, it's just awful.
And ask them to wake up John Doherty for us.
I was at home the night of the call, just relaxing after a day in the office, enjoying a movie, but I was on call. And those pagers would go off, and sure enough, it did.
John Doherty has worked with Captain Hansen for several years.
I knew John very well, so I had a face, a person, a pilot I knew very well in my mind's eye.
I knew John Doherty had a better knowledge of the 747-400 than anybody at Northwest.
But Captain Hansen has no idea when his friend's help might arrive. And keeping the huge aircraft flying level at 35,000 feet is becoming increasingly difficult.
The control wheel was shaking because the whole airplane was shaking.
He decides to descend to a lower altitude, where denser air will provide more lift.
You ready to do this?
All set.
But with a crippled plane, this normally routine procedure will be another risky maneuver.
Okay. Let's go.
You want to do it very carefully. So they're handling the controls under this really unusual circumstance as carefully and gently and as delicately as they can.
How's it feel?
About the same, not great.
We had to be very careful how we flew this airplane. The tail might be coming apart. The rudder might be just barely hanging on, or it could be a hydraulic problem.
28,000.
They make it down to 28,000 feet without further incident.
I think I got this here.
Okay.
But the force required to fly the damaged aircraft has taken its toll on the captain.
John.
Yeah, my leg's starting to cramp up. I'm having a tough time holding this together.
The physical effort that was required was considerable. We were pushing so hard with our leg on that rudder pedal that we could only do it for about 10 minutes.
You're gonna have to take it. Are you ready?
I'm ready.
All right. Nice and easy.
And then Mike would come in as I released.
It wanted to go back the other way. In other words, you had to make it go where you wanted it to go. And you have to use the cross control. So you're using the muscles in your shoulder and in your back, and we would lock our legs.
And then when I would release, I'd kind of get limbered up again.
Still more than an hour away from Anchorage, the flight attendants prepare the cabin for a red emergency.
We did what we were trained to do. It just kicked in, and you would make sure that everything on the counters is put away, make sure all the crew bags are stowed and where they should be. Everyone, to a person, cooperated with what we asked them to do. I remember coming to a family of 3, and they asked me if I was afraid. And I hate to admit it, but I did briefly consider lying. But then I decided that wasn't what I should do.
Yeah, I'm afraid too. But we have the best pilots.
Flight 85, we have John Doherty on the line.
Operations has finally been able to connect the pilots with John Doherty.
John, have you been briefed on this? You know what's happening up here?
Yes. I understand you have a control problem?
ICAS is showing we have a hard over lower rudder.
They were facing really a very confusing situation. They knew they were confronted with something unique. It was something that they had never done in training, something they had never seen in training, nothing we'd ever talked about in ground schools.
Tom is not telling us much. We're an hour out of Anchorage. What do you think?
Well, don't remove any power
from the hydraulics. But other than that...
And I knew from listening to John that what we had in the books wasn't going to be a help to him. There are going to be some circumstances where a pilot is going to have to figure out what to do on his or her own.
30 minutes pass before Northwest 85 is in range to talk to the Anchorage Control Center directly.
Northwest 85, we have you on the radar. Anchorage, Northwest 85, confirm
That you are aware that we have declared an emergency.
that you have emergency equipment standing by.
We will request runway.
The plane must fly over the Aleutian mountain range to reach Anchorage International Airport. The airport itself is also surrounded by mountains.
We said, okay, 6 right is the runway we want because it'll give us a 20-mile final, and it's a great runway with an ILS approach, and it's long.
Okay, 6 right it is. Let's make sure we get it right the first time.
As far as the missed approach is concerned, we're not going to do one. We're just going to do it right the first time. We're going to put it right on the spot.
There is no margin for error. The pilots know they have only one shot.
What do you think, Mike?
Maybe we should start configuring for landing early. Lower our altitude.
They're still 40 minutes away from Anchorage, but the pilots decide to configure for a landing. They want to see how it will affect their crippled plane. If something goes wrong, this may give them more room to recover.
Okay, we can take it over Cook Inlet, lower to 14,000, and then see what happens.
14,000 feet is a real nice intermediate altitude. It's good, thick air, and it's high enough yet that if something got worse and control deteriorated, you'd have room for a recovery.
This is Northwest 85. We would like to descend to
14,000 over Cook Inlet.
We can't do that. Lots of air traffic in that airspace.
The airspace over Cook Inlet is the busiest corridor in this part of the continent. If they lose control of the plane again, they could collide with another aircraft.
This is an emergency aircraft. This is the
Safest course of action.
Okay,
We'll clear everyone out of your way.
The jumbo jet slowly descends to 14,000 feet.
Okay. Flap 5.
flap 5.
As he adds flaps, Captain Hansen can only hope the plane maintains stable flight. Next comes an even bigger test.
Gear down.
Gear down.
Lowering the massive landing gear will increase drag and reduce airspeed. The plane handles the new configuration without any problems. But there are new worries about the damaged rudder.
You feeling that?
Oh, yeah.
The rudder is tied to airspeed and altitude. The lower you get, the further the rudder goes out. So then it required more rudder, more aileron, and that was physically exhausting.
Mike, my leg's starting to cramp up. Are you ready?
I'm ready.
John Doherty is still on the line to the crew. He offers a suggestion.
Have you considered adding
20 knots to your approach speed.
No, we hadn't thought about that.
We'll do it.
The extra speed may help make the plane more controllable.
Hello, ladies and gentlemen. We're in for a bit of a rough landing. When we touch down, there's going to be quite a jolt. We'll tell you when to brace for impact.
As Northwest Airlines Flight 85 approaches Anchorage, the pilots and Doherty continue planning for an uncertain landing ahead.
We discussed how are things going to be as we fly the approach, what flight control, what management issues in terms of flight path we're going to encounter there, and then how are we going to manage directional control during the landing rollout, what stopping issues we're going to have, and so on.
The decisions they face in the next few moments will make the difference between life and death.
Okay, we can't do this anymore. Let's use the engines. Dave, get on the levers. 1 and 2 up, 3 and 4 down.
Just minutes from touchdown, the pilots increase power to the left engines while reducing power to the right. This uneven thrust should help keep it straight. But there is a danger. No one knows how badly damaged the rudder is. If it tears off while the engine thrust is uneven, the pilots will lose all control. On the ground, they are preparing for the worst.
Give $1,000 for a rearview mirror right now. John, what do you think?
Doherty has been scouring charts and manuals. He reminds the crew of another problem to consider.
On landing,
Don't forget the rudder's attached to the
nose steering.
And when that happens, Mike, I'll take the tiller and the brakes. You take the yoke.
Once the nose touches down, the damaged rudder may cause them to lose control of the plane at more than 300 kilometers an hour.
I flew the approach all the way down, and I thought, if there's ever going to be a time that you fly a perfect approach, it's got to be this one.
I became extraneous at that time, so somewhere along around 7,000 to 8,000 feet on the way down, I signed off with the crew.
I'll talk to you
When you're on the ground.
We'll talk soon.
You know, I gave John whatever blessing I could give at the moment, probably understated in typical pilot fashion, and I was off the line and just waiting to hear what happened.
Between the frigid waters of Cook Inlet and the towering Alaskan mountains, Anchorage International Airport awaits the arrival of a stricken 747.
85.
Northwest 85, we have you on our radar.
The passengers and crew of Northwest 85 are now moments away from an emergency landing.
As I was putting my own seatbelt on, I remember thinking to myself, is this all there is? As in, am I done here? Am I going to be alive when this is over? And I thought about my kids and my husband and my home.
Northwest 85, clear to land. Emergency equipment standing by.
Roger, cleared to land.
The crew still has no idea what will happen when the plane touches the ground.
There were close to 400 passengers in that airplane and a crew of 18, and some of them people that I knew personally, like John and the other pilots in the crew. So waiting was hard.
Okay, everyone, here we go.
Touchdown in 5.
Prepare for impact.
Brake! Brake! Brake!
Got it? I got it.
As planned, on touchdown, First Officer Fagan takes the control column. Captain Hansen guides the front wheels with the tiller. The timing is critical. One false step, and the plane could shoot off the runway.
We got it. Good job, Mike. Good job, guys. So what do we do for encore?
Not that.
Everyone in the cockpit was finally able to exhale, and we just went.
Once we were given the signal that it was okay,
Please remain seated until the seatbelt light is off.
I knew that I had to get up and go to that entry door and get these people out of this airplane. We did what we were trained to do. We did a great job.
Controllers can see what the pilots can't.
That's quite the rudder you got there. Must have been a hell of a ride.
Oh, yeah, it was a real joyride.
Almost 2 hours after the emergency began at 35,000 feet, all 404 people on board are safely on the ground.
Well, when I heard the crew was safe, of course, it was an incredible sense of relief. These guys had been tested, and they'd done a fabulous job. So, you know, it was really joyful. I mean, a sense of grace, accomplishment, joy, satisfaction. It was all good.
The pilots have narrowly avoided a fatal crash. But what caused them to lose control in the first place is a question that desperately needs to be answered. Northwest is just one of many airlines flying the 747-400 every day. Thousands of passengers around the world now face a potential risk. Carolyn DeForge of the NTSB will oversee the investigation.
It appeared to be a very dramatic event, and it definitely seemed like something we needed to follow up on and try and understand what had happened.
Investigators immediately discover a trail of hydraulic fluid leaking from the back of the plane.
It was very surprising to us when we found out what type of failure had occurred and that the effects it had had on the aircraft's controllability.
The pilot's foot pedals are linked to the rudder through a hydraulic power control module, or PCM. When the pilot presses on the pedals, the PCM changes the hydraulic pressure, and that's what moves the rudder.
They opened up the access panels in the tail, and they noticed that the end cap on the control module had separated. The end cap is a circular piece about 2.5 inches in diameter, and it had completely fractured all of the way around its diameter and had then fallen off.
With the PCM broken, the pilots had no way to control the lower rudder. The failure of this one piece of engineering nearly brought down the entire plane. The power control module is shipped to the NTSB headquarters in Washington. Close examination reveals exactly how the failed part caused the rudder to jam.
When the end cap came off, it allowed a piston inside the module to move further than its design limit was intended, and that is what resulted in the rudder hardover.
But why the module's end cap failed in the first place is still a mystery.
It was certainly something that was not anticipated by the designers, and when we examined the hardware, it was definitely beyond the scope of what you normally encounter as an engineer when you're doing a failure investigation. Normally you see something that's an internal failure, not an actual mechanical failure of the housing itself.
Sylvie Dion is a metallurgist specializing in airplane components.
The manifold material was an aluminum alloy, which means that it's actually aluminum metal that's mixed in with a bit of copper, with magnesium, with zinc. And the purpose of adding these other elements is to make it stronger.
The aluminium alloy used to make this part is extremely resilient. It should never break apart like this.
Doing failure analyses like this on failed parts is a bit like being a detective, because you're looking for clues as to what caused the occurrence, what caused the material to fail.
The size and shape of the crack tells investigators that the module wore out over time, what's called metal fatigue. However, this is almost impossible for them to believe. A Boeing 747-400 is built for long hauls, 12 to 15-hour flights, and its parts are built to last decades.
My understanding was the mean time before failure for this item was something like 30,000 years, which is basically saying, well, we don't think this part was ever going to fail.
The 747-400 is in high demand. More of these massive planes are being manufactured every year, with the same control module that failed on Flight 85. If this crucial system is wearing out prematurely, investigators need to figure out why, before it leads to a fatal disaster.
The fact that this had a purely fatigue failure with no apparent origin to it such as a deficiency or a defect, made us question the material properties of the housing itself.
Investigators send the unit back to the manufacturer for extensive metallurgical testing.
Metals are made up of little crystals, which metallurgists call grains. And if the grains are too small or too large or not the correct shape, the material may have a different strength, different ductility, different resistance to propagation of a crack.
A visual examination of the metal provides no insight into why it failed.
One of the best techniques for revealing if a part contains cracks or surface defects is to use fluorescent dye inspection. The part is examined under UV light, and the defects will appear as bright lines or bright dots that are very visible.
But the exhaustive tests reveal that the material itself was not to blame. Investigators still can't explain the failure.
It was driving all of the group crazy. We were very frustrated when we realized that all of the paths we chased down didn't give you that aha, eureka moment.
Investigators wonder if something in this plane's history could have caused the module to break down prematurely. What the records reveal is surprising.
Northwest was the launch customer for the 747-400, and this one was the first in the line of 400s that Northwest flew. It was the oldest production 747-400 in the world.
And that's not all. Records also show that this very 747-400 was used as a test plane before it was even sold to the airline. Could rigorous testing have somehow led to the failure of the power control module? The plane had flown for 55,000 hours and taken off more than 7,000 times. That's more takeoffs and landings than most 747s with that number of hours in the air. This discovery leads the investigation in an entirely new direction.
We were concerned that it had been exposed to more stress than we had expected, and that may have caused it to fail.
Each time a plane takes off and lands, its systems are put through more stress than when it's simply flying through the air.
We were very concerned about those operators in Asia that use the 747-400 on short-haul flights.
This module, however, is already broken. There's no way to test it. Checking all the units on the rest of the fleet is not a practical option.
You would have essentially had to have grounded the fleet to remove all of the units.
As a preemptive strike against future failure, the NTSB recommends that airlines test the power control module more vigorously and more regularly.
We instituted a repetitive inspection cycle requirement.
But the root cause of the failure is never found. 4 years later, an Air France cargo plane is forced to make an emergency landing. Once again, the lower rudder has failed on the 747-400. The circumstances are strikingly similar to Northwest Flight 85.
The unit was sent to Parker Hannifin in California for repair, and when they opened the box and looked at it, their eyes got really big. They immediately quarantined it and called everyone and said, "Oh my gosh, you're not going to believe what just showed up on our doorstep."
If the Air France module shows signs of metal fatigue like the one on Flight 85, then investigators may be a step closer to explaining the mysterious failures.
We immediately focused in on the fracture surface again in the same area and did many of the checks that we had done the first time around.
But this case seems to be different. There is no sign of fatigue. Instead, they find a manufacturing defect.
We actually found a deficiency in the bottom of the threaded bore section. We found a very sharp radius at the bottom of the threads, which is where the crack had propagated from.
While finding the cause of this latest failure is significant, it has done nothing to help explain the failure on the Northwest flight 4 years earlier.
Was it overloading? Was it a progressive failure? Was it exposed to something in the environment that caused it to fail?
Without knowing the why, you can't really take the appropriate corrective action. And as an investigator, that's frustrating.
For the second time, a part that was never meant to wear out has nearly brought down a 747. With one of the two near tragedies still unexplained, investigators desperately need to find a fail-safe measure that will protect passengers in the future.
Okay, everyone, here we go.
4 years after Flight 85's heart-stopping emergency landing in Anchorage, the cause of the 747's rudder failure is still unknown. Now the same part has failed on another flight. The next failure could be deadly.
We still don't know actually the root cause of the Northwest failure. But because of what we found with the second Air France failure, we needed to take corrective action to prevent similar failures from occurring.
Investigators recommend attaching special plugs to the control module. In the event of another failure, these new pieces will prevent the rudder from moving too far in either direction.
The changes that we've made to the control modules in the 747-400 fleet will prevent any future events of a rudder hardover.
An airworthiness directive from the FAA makes it mandatory for every 747-400 to be fitted with this new technology, eliminating the risk of another failure. But still, there is another question to consider. One investigators seldom have the luxury to contemplate. With a catastrophic failure of the rudder system, why didn't Flight 85 crash? One reason: the very design of this 747.
Having a split rudder is definitely an unusual feature of this airplane. And in this case, it worked in their favor in the sense that if there had only been one rudder and the actuator of that rudder had failed, then 100% of the yaw control would have been deflected, which would have magnified the problem.
But technology alone did not save 404 lives. In 1985, China Airlines Flight 006 also went into a sudden roll. But that flight plummeted nearly 30,000 feet before the pilots were able to regain control. How had Flight 85 escaped the same fate?
If Frank hadn't reacted the way he had, we probably would not be here to tell the story.
Frank, have you got it?
Yes, I think I've got it.
Captain Geib's actions in the first few seconds were critical to saving the plane. But what got it safely to the ground is another story.
Every pilot in that cockpit knew what was going on. Risks were being assessed and so on.
On landing.
Don't forget the rudder's attached to the nose steering.
And when that happens, Mike, I'll take the tiller and the brakes, and you take the yoke.
Cockpit resource management is really what enabled us to think this thing through and get the airplane on the ground.
I am proud to say we were like a well-oiled machine. We all did what we were trained to do.
Touchdown in 5. Prepare for impact.
And not one single person fell apart.
What do we tell the captain?
Guys that we had in the cockpit were just tremendous. Everybody communicated.
I'll go back and tell them. The more they know, the better.
I agree. I think we should tell them exactly what's going on.
I think this crew did a phenomenal job in getting this aircraft back on the ground safely.
In 2003, the Airline Pilots Association awarded the crew of Northwest Airlines Flight 85 with the Superior Airmanship Award.
More important than the award was the fact that we got the people on the ground safely.
We got it.
In this day and age of automated cockpits, hand flying is in danger of becoming a lost art. We have to remember as pilots that we are there because of our flying skills. We had prepared so well for this thing that the failure was not an option.
A Boeing MD-87 cuts through the morning fog.
The accident was inevitable. They were doomed.
The plane, carrying 110 people, erupts in flames at Milan's Linate airport.
This is the most serious accident in the history in Italy.
Incredibly, no one at the airport has noticed the catastrophe.
Hello, this is Tower.
No, nothing.
Valuable minutes pass.
It was astonishing. Air traffic control still doesn't know what happened.
Only when the wounded come looking for help.
There's a red streak of fire at the end of the runway.
Do authorities begin to realize that something is seriously amiss?
My God.
At one of Europe's busiest airports.
Mayday, Mayday.
Milan. Fashion capital of Europe and Italy's economic and financial heart. Milan is served by 3 international airports. Only one, Linate Airport, lies within city limits. It handles 9 million passengers a year on short flights all across Europe.
Alitalia 226, airborne, 05.
On the morning of October the 8th, 2001, dense fog shrouds the airport.
The fog that day was very bad, and the general visibility was about 50 and 100 meters.
In the tower, controllers have a heavy workload. There are nearly 24 aircraft to get off the ground in the next 60 minutes.
Alitalia 2120, buongiorno, startup.
They handle nearly 500 radio communications every hour.
Linate, buongiorno. Delta, India, Echo, Victor X-ray. Requesting startup.
Delta, Victor X-ray. You are cleared to start your engines.
Brown, Scandinavian 686, request taxi from 13.
Scandinavian 686, taxi to holding position, Cat 3.
Scandinavian 686, taxi to holding position, Cat 3.
One of today's flights is Scandinavian Airlines Flight 686. The Boeing MD-87 is scheduled for a routine flight to Copenhagen, Denmark. There are 110 people on board.
Taxi holding point, Cat 3.
The captain is Joachim Gustafsson. He's been with SAS for more than a decade.
Scandinavian 686, your position, please.
We still haven't reached the main taxiway, Scandinavian 686.
First Officer Anders Highlander has been flying for the airline for the past 4 years and has clocked 2,000 hours on the MD-87.
The SAS crew were very highly experienced pilots, so couldn't ask more for 2 qualified pilots.
With thick fog blanketing the airport, the pilots have almost no visibility. They must rely entirely on instructions from air traffic controllers as they navigate their way to the runway.
There are a lot of taxiway, one runway for commercial aviation, and there are a lot of many different types of airplanes in Linate, so it's a very busy airport.
High above the runway, air traffic controllers normally have a clear view of the airport, but not today.
Air 1937, where are you?
Between 18 and Delta.
So you're practically in front of the tower, right?
Paolo Zacchetti is the ground controller responsible for guiding flights to the start of the runway, where planes take off every 2 minutes.
Taxi north via Romeo 5. Call me back at the stop bar of the main runway extension.
With Linate fogbound, he's got his hands full.
Scandinavian 686, your position, please.
Now you're on the main taxiway.
Yes, now we are entering the main taxiway, Scandinavian 686.
At 8:01 a.m., Zacchetti hands SAS 686 over to the tower controller for final takeoff instructions.
Tower, buongiorno, Scandinavian 686, sequence to 36 right.
Ciao, Scandinavian 686, line up and wait 36 right.
Line up and wait 36.
The SAS crew must wait behind other planes taking off from Linate's main runway, 36 right.
Alitalia 226, cleared for takeoff, 36. Report when rolling.
Low visibility is not a problem in air. It's a very big problem on the ground because pilots depend completely upon the air traffic controller.
Delta Victor X-ray. Confirm your position?
Approaching Sierra 4.
Roger. Maintain the stop bar. I'll call you back.
Takeoff data.
57 tons, and it is checked.
Checklist complete.
Scandinavian 686, Linate.
The wind is calm. Report rolling.
When airborne, squawk ident.
Once the plane ahead has taken off, Flight 686 begins its takeoff roll down the airport's 2,400-meter-long runway.
And we are rolling, Scandinavian 686.
Auto throttle on. Set thrust.
V1.
At a speed of 140 knots,
Rotate.
the pilots lift the plane off the ground.
What's that?
Something catastrophic has happened to Flight 686. But because of the thick fog, no one in the control tower has any idea.
It was astonishing, so close to the tower, and nobody was aware about this.
Out on the tarmac, ground workers have heard a series of loud noises.
Hello, this is Tower.
We heard a number of bangs like an engine.
We heard it too, but we don't know what it was. It seemed as if somebody was climbing these steps.
You don't have anything abnormal?
A passenger jet has been in flames for nearly a minute at one of Europe's busiest airports. But so far, no one knows.
No, nothing.
This was incredible to believe that this big accident happened and nobody could see what was happening in that moment.
The crash site goes undiscovered until a customs officer spots an injured baggage handler stumbling from the wreckage.
It took a while to figure out that they had a big disaster on their hands.
The officer alerts emergency crews. But the controllers still don't know there's been an accident.
Incredibly, Linate Air Traffic Control still doesn't know what happened.
Only now does the tower controller check for the SAS flight on his radar. He can't find it.
The radar does not show the plane flying away from Linate.
Then they get a radio call from another plane.
There's a red streak of fire at the end of the runway.
Finally, almost 3 minutes after the accident, Linate Air Traffic Control raises the general alarm. They ground all departing planes and close the airport to incoming traffic. Scandinavian Airlines Flight 686 has crashed and exploded on takeoff. But no one yet knows the true scope of this disaster. Ten tons of jet fuel feed a massive fire where a Boeing MD-87 has collided with an airport building.
Awful, terrible devastation, the collapse of a roof of the hangar, and the saucer plane completely destroyed in many different parts, and unfortunately the dead bodies. The rescue people had problems to enter a cargo building to rescue victims because the airplanes was blocking the entrance.
Some 14 minutes have passed since the crash. As emergency crews battle the fire, Linate air traffic controllers frantically try to understand what just happened.
There are 2 aircraft unaccounted for.
Paolo Zacchetti discovers a private Cessna Citation did not return to its parking position after all planes were grounded.
The main attention was focused on the saucer plane, so nobody thought that there was another plane.
A private aircraft is missing, a Cessna 525.
Ground crews search for the missing plane. Finally, 26 minutes after the crash, they find the Cessna burning and in pieces, halfway down runway 36R. It appears there's been a collision.
It's hard to believe that after half an hour, people became aware about the fact that the Cessna was on the main runway.
There is another aircraft in the accident near Romeo 6.
Air traffic controllers are mystified. How did these 2 planes end up on the same runway at the same time?
What's that?
2 planes are destroyed. A hangar is in ruins. The scope of the tragedy is overwhelming. It's soon clear that no one from either plane has survived. The crash has killed 110 people on the SAS flight and 4 on board the Cessna. Inside the collapsed hangar, 4 more people have died. 118 fatalities in all.
This is the most serious accident in the history in Italy.
You can't imagine. I haven't taken it all in.
I heard 3 explosions. Boom, 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 and then a huge flame, a long one.
First there was a crash. Then this hot air that was inside. This extremely hot air that burnt my head.
My God.
Mario Pica is the lead investigator for Italy's National Agency for Flight Safety, the ANSV, but he's not in command of the crash site.
It took me a few hours to get access to the scene of the accident.
Unlike most countries, Italy treats aviation accidents as crimes. The police get priority at the scene.
After an air crash in Italy, the criminal investigation automatically begins, and the police is involved in analyzing this event.
Pica has a different goal.
It was mandatory to find out really what happened and find the reasons that could help us to avoid it happening again.
Grazie.
First thing I remember was to have a look at the baggage hangar, where the rescue workers were still busy taking out pieces of rubble at the aircraft and looking for bodies and possibly survivors. I decided to go and have a look at the Cessna that was still on the runway. I just sketched the first map of the position of the various pieces of the debris to reconstruct the dynamics of impact. And they were intermingled, pieces from the Cessna and pieces from the MD-87.
As lead investigator and a pilot, Pica knows the most valuable information in any air disaster comes from the black boxes. But the Cessna was not equipped with either a cockpit voice recorder or a flight data recorder.
The absence of the flight recorders were really a drawback because they are very helpful in any investigation to precisely define what happened.
The Swedish Accident Investigation Board sends a team to Milan. It includes technical specialist Tom Zollner and lead investigator Frank Christensen from SAS. They will work with Pica to unravel the accident.
We were called to be part of the investigation as it was in the Scandinavian Airlines plane.
I guess we'll have to wait for authorization.
We realized that the investigation in Italy was different what we learned. In Italy, they conducted as a criminal investigation, and we as investigators has to wait.
Damn.
We're really not happy about that. We would like to see what the planes looked like, how the accident site looked like. We were not allowed to be near the accident site.
The media worldwide attention was on the Linate disaster.
The SAS airliner headed for Copenhagen slammed into the private
And
jet.
so what happened in Linate? What were the main causes of this accident? What were the main responsibilities for this?
Investigators soon make a troubling discovery about Linate Airport.
So, you're telling me there have been a lot of these incidents before?
Air traffic controllers reported we have an average of nearly one runway incursion per week.
It appears the 9 million people who use this airport every year have been in danger for some time.
There have been other runway incursions. This was shocking.
Less than a month before the collision, a near miss on the same runway.
With an aircraft entering the runway while another aircraft was taking off.
It was really a big shock for us that it happened that often at the Linate airport.
Clearly, something is very wrong at Linate. The morning after the crash, investigators face national and international pressure to figure out what it is.
Meanwhile, there were prayers for victims of the crash, Italy's worst ever civil aviation disaster.
Finally, the entire investigative team is given access to the crash site.
All of us were trained investigators, and we knew what we were going to investigate and how to do it.
But authorities have thrown a major obstacle in their path.
So where's the plane?
The police have ordered airport workers to move the debris off the runway and away from the baggage hangar.
We got very angry. The removal of the debris actually removed a lot of valid information, which we now never could see.
Debris from both planes has been piled on a concrete helicopter pad. Locating Flight 686's voice recorder will be a huge challenge.
We couldn't find the cockpit voice recorder.
The importance to find the CVR was to check if the crew realized the collision was actually going to take place and see how well they were trying to avoid it.
We can't know what the crew were doing without the CVR. We had to learn about the possible takeoff clearance and if there were crew errors. Did they receive a takeoff clearance or did they not?
Here's what we know so far. The MD-87.
Measuring the distance, we ascertained that the MD-87 had traveled for about 40 seconds and gone 1,500 meters before striking the Cessna. It was clear that A collision had occurred on the main runway at the interception from taxiway. The MD-87 had continued its run, deviating slightly to the right until hitting the baggage hangar.
Here.
Weather reports show that visibility was only 50 meters at the time of the collision.
With the heavy fog of that morning, it was clear that the environmental factor was a contributing cause of the event.
V1, rotate.
Imagine an aircraft traveling at 72 meters per second. What reaction time would have needed to avoid the collision?
The SAS pilots would not have been able to see the Cessna on the runway until a split second before impact.
What's that?
But fog should not cripple a major airport like Linate. Modern airports use a system of regulations and safety equipment when operating in low visibility.
Airports avoid incursions by having a defined low visibility operating rules. These rules can be augmented by technology, ground radars, alarm systems, and other things.
Airport runways and taxiways are broken down into a series of checkpoints known as stop bars. Aircraft must always wait for authorization before passing, like a car must wait for a green light. The system is designed to keep planes from colliding.
Planes can avoid each other at night, so why should there be any difference in fog?
We have to consider this right off the bat.
One of the first thoughts that came to mind was
pilot error.
The possibility of a pilot error.
One of the pilots was not where he was supposed to be. Investigators need to know which one. The worst air disaster in history occurred under eerily similar conditions. On the island of Tenerife in 1977, "583 people died when two Boeing 747s collided on the runway in heavy fog."
In comparison with the Tenerife accident, it was both in dense fog, taxiing on the wrong taxiway was involved. Communication was also involved, as the KLM captain thought he heard a takeoff clearance, but he didn't.
Investigators wonder if the Linate disaster is a case of history repeating itself. They learned that the brand new Cessna Citation jet had arrived in Milan following a flight from Germany. The German crew was now taking two passengers to Paris. Since the Cessna was not equipped with a cockpit voice recorder, and the CVR from SAS Flight 686 has not yet been found, investigators have only one record of what happened: the air traffic control recordings.
We have to listen to the facts. Our expectation was that the ATC recording would reveal what actually was being said that morning.
Investigators paid close attention to Paolo Zacchetti's conversations with the Cessna, call sign Delta Victor X-ray.
Delta Victor X-ray, taxi north via Romeo 5. Call me back at the stop bar of the main runway extension.
Roger, via Romeo 5. Call you back before reaching main runway.
The Cessna was instructed to go north from the apron, along taxiway Romeo 5, to a taxiway that runs parallel to runway 36R. The route should have kept the Cessna off the runway.
But he ended up here instead.
Investigators make a shocking discovery. The Cessna went south from the apron, not north as instructed. It now appears the pilots made the fatal error that caused the accident.
Call you back before reaching main runway.
The control tower recording makes it clear. The Cessna pilots got lost on the way to the runway.
The Cessna didn't follow the taxiway Romeo 5 for which it had been authorized, but took instead taxiway Romeo 6.
The revelation leads to an important question.
So why didn't anyone notice?
Delta Victor X-ray, continue your taxi on the main apron.
Roger. Continues the taxi on main apron, Delta Victor X-ray.
That is correct, and please call me back entering the main taxiway.
Main apron? Main taxiway?
The recording reveals that the air traffic controller did not clearly distinguish between aprons and taxiways. His choice of words may have led the Cessna pilots to believe they were headed the right way. An apron is a restricted section of an airport where planes park, are loaded or refueled. Taxiways are roads from the apron to the runway.
The communication with the tower and the pilots that morning of the accident was inconsistent. They used the word main for different things. Main runway, main apron, main taxiway.
And please call me back entering the main taxiway.
But Linate Airport has several aprons and taxiways. None of them designated as main.
So that was a communication below acceptable standard.
Play that again.
Investigators also hear a puzzling transmission from the Cessna.
Approaching Sierra 4.
I don't see it anywhere.
It's not here.
Listening to the communications, I was baffled when I heard pilot reporting a Sierra 4.
The controller's maps don't show S4 at all. Investigators are beginning to suspect the error goes beyond the poor communications between Zacchetti and the Cessna.
Approaching Sierra 4. Sierra 4.
I asked him if he knew where Sierra 4 was.
Where is Sierra 4? I have no idea.
That was very simple. He confessed he didn't know where Sierra 4 was.
Pica finds that Zacchetti's managers never gave him a tour of the taxiways as part of his training.
Approaching Sierra 4.
Delta Victor X-ray. Roger. Maintain the stop bar. I'll call you back.
He had no way of knowing where Sierra 4 was. The Cessna now has to cross the runway to get to the apron. He keeps going, past several signs that he's approaching an active runway.
Air traffic controller didn't stop the Cessna.
Delta Victor X-ray.
At that moment, the tower clears the MD-87 for takeoff.
Scandinavian 686 Linate, cleared for takeoff.
Continue your taxi on the main apron.
He should have stopped the Cessna, but unfortunately...
Roger, continues the taxi on main apron.
He thought that the Cessna was on R5 taxiway.
The Cessna pilot makes a fatal mistake. With the MD-87 now traveling at 260 kilometers an hour, he taxis across the runway. Suspicions about procedures at Linate Airport deepen as investigators learn that the exact same mistakes that led to the deadly collision were made by another plane less than 24 hours earlier.
Frank, come and look at this.
I was shocked to find out that only the previous afternoon...
Same thing, 24 hours before.
An aircraft had been cleared by the air traffic controller to taxi onto Romeo 5.
24 hours, it happens here all the time.
The aircraft taxied really onto Romeo 6.
Because there was no fog that day, the two planes saw each other and did not collide. Investigators are beginning to suspect that something about the airport, not bad pilots, may be the cause of the Linate crash and the frequent runway incursions there.
When we found out that the Cessna pilot had taken the wrong taxiway, first question was to explain what did he see that brought him so much off course.
Okay, this is where they started.
The taxiway we went on was Romeo 6, and we walked the whole length of the taxiway.
We wanted to put ourselves in the shoes of the pilot to understand his actions.
They look for route identification signs that are supposed to help guide the pilots.
The status of those markings were in a very poor condition. It was surrounded by high grass, and there was only a very few of those markings.
The markings painted directly onto the tarmac are also vital for pilots.
When we came to the intersection between Romeo 5 and Romeo 6, we could see that the markings on the ground were so badly painted that even in good visibility it was difficult to read them. Which made us understand that for a pilot not familiar with the place, it would have been difficult to understand where was Romeo 5, where was Romeo 6.
The faded markings help explain why the Cessna turned right when it should have turned left to avoid the runway. They also come upon the reason the Cessna pilot referred to the unknown position Sierra 4.
Approaching Sierra 4.
There's Sierra 4, but it's not on the map.
Actually, Sierra 4 was a marking on the Romeo 6 taxiway going towards the runway, but were not reported on any official map.
Approaching Sierra 4.
Delta Victor X-ray. Roger.
Had the controller known where Sierra 4 was, he would have realized the Cessna was headed the wrong way and approaching the runway. But inadequate markings and maps still don't explain the collision. Linate, like all modern airports, is equipped with motion sensor alarms to guard against runway incursion.
Even with the failures of all other systems, the acoustic alarms should have worked, and we wondered why it didn't work.
Reading the ATC communication recordings, we couldn't find any alarm going on when the Cessna aircraft crossed the stop bars and entered the runway.
Pica decides to test the runway incursion sensors himself.
I was told that possibly they didn't work, but we wanted to be certain.
Okay, commencing test of the motion sensor alarm on taxiway Romeo 6.
So, one night, when the airport was closed, we made an experiment going over and over through the sensors, but we had a man on the tower just to make sure that the alarm didn't go.
Anything?
No, nothing.
Again.
Eventually, we found out that those alarms had been deactivated years before to avoid unnecessary alarms that were triggered eventually by an animal crossing or a car doing an inspection during the night.
1 week after the accident, investigators still have not located the cockpit voice recorder amid the aircraft wreckage.
Finding the CVR was crucial in order to establish that there was no problems prior to impact.
So I decided to sort through this giant pile of rubble and concrete and steel, and eventually we did find the CVR.
The CVR of the MD-87 was carefully analyzed to find out what had been said on board, what kind of procedures were being done.
Scandinavian 686 Linate, clear for takeoff 36.
The recording shows that the SAS crew did receive the proper clearance to proceed down runway 36R.
Cleared for takeoff 36 set.
The SAS crew played no role in causing the accident. They were the victims of the airport's failings. The investigation has identified one final factor that underlines how dangerous conditions at Linate had become.
No. There is no ground radar at Linate. We have not had it in years.
The ground radar of Linate, the old one was dismantled. The new one was in boxes, had been there for years and not yet installed. Why? I don't know.
Airport ground radar systems detect movement of all aircraft and vehicles. A vital piece of safety equipment at a busy airport.
If you have ground radar, it's a good tool to establish what's going on at the airport, even in low visibility conditions.
We can certainly say that if the ground movement control radar had been in place, the ground controller would have had the opportunity to see the aircraft crossing the stop bars, and possibly then would have stopped the aircraft before the collision happened.
Delta Victor X-ray. Confirm your position?
The Cessna took the wrong path due to flawed taxiway markings. Without ground radar, controllers couldn't properly monitor the movement of the Cessna. Add fog into the mix, and disaster was inevitable.
When the Cessna and the SAS aircraft started moving, they were both doomed. The accident was now inevitable.
Scandinavian 686 Linate, clear for takeoff 36.
Delta Victor X-ray. Continue your taxi on the main apron.
And we are rolling, Scandinavian 686.
Roger, continues the taxi on main apron.
V1, rotate.
What's that?
The cockpit voice recorder gives investigators a detailed picture of what happened at the moment of impact.
Noises in the cockpit would also tell us the different controls being moved, and the ambient noise from the area mic would give us information of some of the sounds during the collision.
What's that?
We realized that the impact was more than one collision. It was actually several collisions in half a second.
When that half second of audio is analyzed more closely, investigators discover it contains several distinct sounds.
So we exposed this data over the schematic of the aircraft, showing the travel of the sound. By doing that, we could analyze that we have several points of impact during the collision.
The painstaking research gives investigators a better understanding of how the two planes came together on the runway.
The MD-87 first hit the Cessna with its nose landing gear at the Cessna stabilizer. And then, in a short order of time, the left-hand main landing gear of the MD-87 hit the outer part of the right-hand wing of the Cessna, and then the biggest impact was the right-hand main landing gear of the MD-87, cutting through the cabin of the Cessna.
Investigators conclude the MD-87 lost its right engine after the impact. The plane would have been almost impossible to fly. But remarkably, the pilots almost managed to do just that.
After the collision, the MD-87 did actually got into the air.
According to the flight data recorder, the aircraft was airborne almost 9 seconds.
The captain made a heroic attempt to fly the airplane. Come on. He tried to accelerate the left-hand engine and use it. But they had ingested too much debris.
And the pilot did an amazing work trying to control it. Up to the last minute, he tried to avoid impact.
The pilots could not have done anything to avoid this accident because the aircraft was traveling too fast. Such a big aircraft cannot respond on a dime. It's impossible. I believe that both crew and both airplanes think they did everything right until the moment of impact.
It's now clear that a badly flawed control system at Linate Airport led directly to the crash. What's more, it's beginning to look like organizational failures may also have prevented rescue personnel from saving lives.
How long was it before the general alarm was sounded?
The investigation begins to uncover evidence of how failures at the airport made a bad situation
Please call me back entering the main taxiway.
even worse.
Hello, this is Tower. The wreckage of the Cessna was found only about 25 minutes after the accident. And by the time the fire brigade arrived on the scene, all the occupants were dead.
Post-mortem exams confirm that 3 people in the Cessna had high concentrations of smoke in their lungs. They were still alive after being hit by the MD-87.
They were burned alive.
After the collision, the Cessna burned for more than 20 minutes.
If the rescue to the Cessna had arrived earlier, certainly the 2 pilots would have survived the accident.
After more than 6 months of painstaking investigation, Mario Pica delivers his findings. Though runway incursion by the Cessna is listed as the immediate cause of the accident, Pica does not entirely blame the Cessna pilot. Instead, he points to the lack of proper signage and taxiway markings at Linate, as well as to the airport's failings overall.
A fairly simple airport like Linate with only one main runway, it should be easy to cover this with the signs and with the paintings and so forth. But apparently everything which could go wrong did go wrong at that airport.
Delta Victor X-ray, taxi north via Romeo 5. Call me back at the stop bar of the main runway extension.
And for some of the people involved, the fallout is especially harsh. Ground controller Paolo Zacchetti, along with high-ranking officials from the agencies which oversee Linate, are handed prison sentences. The judgment sparked intense debate. Should human error in air accidents be considered a criminal act?
I defined the ground controller as the 119th victim of the case.
I didn't have the equipment that could have made me aware of what was happening.
Delta Victor X-ray, continue your taxi on the main apron.
Roger.
Yes, it is true he did make a mistake, but he is the result of a system that failed.
Because of the tragedy, Linate Airport underwent a major overhaul designed to improve safety.
Linate improved the airport by installing the ground radar. Some of the markings and signage was repainted.
The runway incursion alarm are functioning now.
Alitalia 212, hold your position. You are crossing an active runway. Repeat, hold your position. Alitalia 212.
A big lesson learned in this accident, in my opinion, is that people are prone to get used to failures.
There is no ground radar at Linate.
Accepting latent conditions, getting used to a system that doesn't work, and by time, actually getting the whole system more and more dangerous.
An airport is a highly complicated place. There's vehicles, there's airplanes, baggage lorries, cargo lorries, all sorts of activities going around at the same time. There have to be a very high level of safety in an airport.
The reforms ushered in following the collision on 36R have made runway incursions far less likely and made Linate a much safer airport.